Dear colleagues, I am pleased to present the results of your work to you. The work was performed at Franko National University of Lviv. My name is Katerynchuk. I am Associate Professor of Optoelectronics and Information Technologies departments. The multilayer neural network used for the recognition of the printed numbers. The conducted studies of the learning error function when using the optimization learning method such AdamMax, AMSGrad proves that the methods do not affect the value of the optimization learning speed and it does not depend on the change of the optimization parameter beta 2. For all considered optimization method, optimal learning speed is 0.45. We deals with the two-dimensional array. We use 3x5 and 4x7 arrays. The sample will consist of 5 options for presenting the number without distortion and with. If array consists 1 or 0 distortion, we call it homogeneous, otherwise non-homogeneous or heterogeneous. We use the mapping function to analyze the error functions. Figures on the slide shows the Fourier spectra and the learning speed that corresponds to the retraining of the neural network alpha equals 0.9 and the branching diagram for n equal 100 iteration. According to figure, the Fourier spectrum is characterized by a wide range of the existing harmonics. According to the branching diagram, starting with the learning speed of alpha bigger than 0.45, the process of appearance of the local minimum should be followed. That is, the future increase in the learning speed begins to be described by a process of doubling of the number of local minima in the learning error function. In the final case, this leads to appearance of chaotic behavior of the learning error function. Considering in the combination with Fourier spectra and branching diagrams, the conclusion is suggested that the increase in the number of harmonic on the Fourier spectra and the number of the branches on the branching diagram is associated with the appearance of the local minimuma in the behavior of the target error functions. And the appearance of local minimuma is due to retraining of neurons. The determination of the value of the learning speed and with the process of the appearance of local minimum due to the retraining process of the neuron takes place. This mechanism assumes that absence of the local minimum out for the retraining regime. The algorithm of the solving this problem consists in determining the optimal value of the learning speed and to for the optimal value of the learning error and when the first harmonic occurs on the learning error function. Under these conditions, the obtained optimal value of the learning speed alpha is equal to 0.4501 for each digit. On this slide, we can see the quality of training and testing represented by this slide and show good results of the training. So the change of the beta 2 parameters for the homogeneous or non-homogeneous input array doesn't affect the training results when using the Adam optimization method. Beta 2 represents the exponential desire rate for the second moment estimates in Adam method, increasing the dimension of the array from 3 by 5 to 4 by 7 cases a decrease in the learning error not only for the homogeneous array but also for the non-homogeneous array. The AdamMax optimization method is an improvement version of the Adam optimization method. AdamMax uses the maximum value of the absolute value of the gradient for each parameter instead of using the average of the square of the gradient as is Adam. This allows us to focus on the large gradient, which can improve the stability of the method. The Fourier spectra and branching diagram for AdamMax shows the same results as for Adam optimization's method. Changing the value of the optimization parameter beta to affect the testing error both for a homogeneous array and for a non-homogeneous array. Increasing the value of beta 2 cases a decrease in the testing error by almost and order to magnitude at 100 iteration. First, the learning quality curve is higher than the corresponding test curve. By increasing the parameter beta 2 for homogeneous array, the expansions of the iteration interval in which there are sharp change of the steepness of the dependence can be traced. That is, the larger the value of the beta 2 parameter, the greater the number of iteration required to achieve the certain testing accuracy. For a non-homogeneous array, the quality of testing and testing when the parameter beta 2 increases improves. The interval of the sharp change in each iteration decreases at the beginning, but the increases again. Such a feature of the behavior, both learning and testing errors from the number of iterations as noted above, attested to the important role of large gradient that improves the stability and the learning speed of the neural network when using the optimization method AdamMax compared to Adam optimization method. The main idea of the AMSGrad is to fix the problem of increasing the value of second-order moment estimates in Adam. The Fourier spectra and branching diagram for AMSGrad shows some results as for Adam optimization method. Changing the value of the optimization parameter beta 2 affects the testing error both for a homogeneous array and for a non-homogeneous array. Increasing the value of the beta 2 cases a decrease in the testing error by almost of the order of magnitude for a homogeneous array and almost by an order of magnitude of the non-homogeneous array at 100 iterations. The dependencies of the training quality 1 and testing quality red curve shown on the slide. The interval of sharp change of your dependence on the number of the iteration depends on both the optimization parameter beta 2 and the homogeneous of the input array. For a non-homogeneous array as mentioned above, the training error is smaller than in the testing error. So satisfactory learning process with minimal learning error observed when the learning speed value equal to the optimum. The appearance of the first harmonic on the first Fourier spectra of the learning error function is correspondent to optimal learning speed. The optimization method of learning AdamMax AMSGrad do not affect on the value of the optimal learning speed. The obtained Fourier spectra of the learning error function branching diagram and the special behavior of the error function when the using optimization learning methods proves that the main reason for the appearance of the local minimum of the error function is the learning process. Dear colleagues, thanks you for attention.